Very good evening, guys. So we will just start the session in next 2 minutes. We are just waiting for the few more candidates. अरुण सेशन में हो यार सेशन में ब्रो हाँ हेलो हाँ श्वेता सर आई start the session or should I wait for 2 minutes or what? Can I start? ओके ओके कितने लोग हैं अभी? हेलो हाँ हाँ मैं वहाँ बोलूँगा तो मेरे को व्हाट्सएप मैसेज करना कि माय वॉइस इज ऑडिबल और नॉट. ठीक है. Okay, guys. So very good evening. So I think we shall start. If anybody wants to join, so they can join in between. All right. So yeah, I believe Vinayak has taken the Python classes. So you guys are pretty much aware of the Python. And so today we will start about hands-on machine learning. And I will be taking this part. Then Shweta will take care of the rest, maybe AI, and after that we'll go for NLP. So I would really like to thank to Shweta, like she has given me the opportunity. So all right, guys. So like today's session is all about hands-on machine learning. I think I'm audible. If I'm not audible, you can maybe you can ping on the comment box. Hello, Vinayak. I have already started. Like, can you hear my voice over there? Okay, okay, yeah. Okay, all right. Okay, all right, guys. I think there was little technical glitch. So like maybe you guys were not able to hear me, but now I think it's fine. Okay, so today we will learn about hands-on machine learning. This is the part one. So okay, so first we try to understand what is machine learning. So I think many of you has already aware what exactly is machine learning, and maybe for a few of them it's like very new, like a new term. So machine learning is so I will break into a very layman language so that it will be easy for you to understand. So see, we have already done this thing in past decades, but we are not aware of that, like what exactly machine learning is all about. So let's say if I say what is the person age and its salary. Okay, so like we can simply plot in a x and y plot what is the age of the person and how much salary he is earning. So this is a typical example of like of any like algorithm. But what if like if we're trying to find maybe a city, like the person like belongs from which city, whether he's a married or not, and like whether like how far he is staying, or maybe like all this term. So when we have the multiple features, like when we have the multiple factors which is affecting his salary, or maybe like we can predict something, so that is when the machine learnings like perform really well. So we'll learn about like more about this. Like I will be giving you a lot of examples on machine learning, then maybe like your doubts may get clear. So firstly, like machine learning is the science of teaching machines, like so we are giving the inputs to machine so that they can learn by themselves. Now you might be thinking like why on earth like we need a machine to learn, because when the humans are already there to do any specific task, right? So here the thing is like this is the typical definition of machine learning. The machine learning is an application of artificial intelligence that provides system the ability to automatically learn and improve from experience without being explicitly programmed. So when we talk about the machines, this is nothing but like this is the machine learning model. Like so we will give the input to the machines, because machine is something which is like they can't like perform by themselves. So we have to give the inputs, and then the machine will learn by his own experience and like perform. So let's say this is the this example I have took. So you can say like, yeah, like for example there's a one task called mopping and cleaning the floor, and when a human does the task, like the quality become vary, because everyone like has their own efficiency to complete and to work in a task in their own particular manner, correct? Maybe few of them get exhausted, few of them get like more working hours, and few get them get sick or something. So we have to like calculate all this man working hour. So that is when like the machine learnings perform really well in those platform, so that we can improve our efficiency at the same time, like we can distribute the equal amount of work, and like our task should be assigned in such a manner so that we can attain the efficiency, right? So that is what like it's clearly mentioned, enables machine to learn on by their own. So machine will learn by its own experience, and machine will decide like how much time it will take to finish that particular task. So in order to answer your question, like suppose like when we are cleaning the floor, like so how much time it will take, like whether the floor needs cleaning or mopping. So like see what I would say, like there is a wooden cart, and we have the lot of different instrument to like to break that cart. Maybe a screw, maybe a like a bolt, or maybe a hammer, or maybe a like uh, a saw machine or something. So what kind of machines we need uh, to break that particular wood, that particular like log of wood. So that is why the like the machine learning will decide like for which particular task or for which particular like for like you can say the given specific like the problem statement, what kind of approach we should need. So that is when the machine learning like helps in a very like proficient manner, like whether the floor needs cleaning or mopping, and how long does the floor need to be cleaned. That is something which we are talking about the prediction. Like we can able to predict like how much time it will take. So we like as like as like we go for the upcoming classes, so I think your doubt may get clear. So no need to confuse much, because we'll have the lot of like the case studies and the lot of coding stuff, so I will explain like in a more detailed manner. But yeah, this is something which you can like hang off what is the machine learning all about. All right. Now yeah, so this is something again like the model then uses this data to predict things like whether the floor needs cleaning or not, and how long does it need to be cleaned. It will take 1 hour, it will take 2 hour or 3 hour. So because if the five like the person are doing this perform like maybe this particular task, so it will take might be 5 hours or maybe 10 hours. but the machine can definitely decide by its own, learning by its previous experience. Yeah. So now, uh yeah, so why in the world we need, how do machine learn now? Yeah, we in everyone's mind, we have the questions running, how does the machine learn? So machine will not learn automatically by himself, because we are the one who has to give the inputs. So we need to collect the data. Okay, like what kind of specific data we need for any particular task, and what are the desired outcomes we are achieving. So we have to fix the certain things in our mind, like what kind of data we should need, and what kind of the what kind of the task, or what kind of the outcomes we really want. Accordingly the machine learns, the machine learning works. Yeah, like here in the second paragraph, you can clearly see machine learning would help the machine understand the kind of cleaning, the intensity of cleaning, the duration of cleaning based on the condition and the nature of floor. That means the so machine will perform, or machine will decide its own specific task according to the external factors, like the different features, whether the weather condition is good or not, whether the the floor is very shaggy, or maybe a very rough, whatever it is. So machine will decide accordingly. All right. Yeah. So now moving ahead. Yeah, so we can see about, so in the today's lesson, we will not go to the very deep dive into the any coding stuff, or any the fancy machine learning model and stuff. So today's class is all about just a basic introduction of what is machine learning, what its application, and and yeah, maybe a little bit of data visualization and data manipulation and stuff. And maybe from the next class we'll go directly into the machine learning algorithms and the use case. All right. Yeah. So here are the application of machine learning in day-to-day life. See, in our everyday life, we are surrounded by the mobile phones, the computers, or maybe the cars, or whatever it is. So everything is related to somewhere or the other is machine learning. Like the smartphone detecting faces while taking photos or unlocking themselves. So I think many of us, we all use smartphones, and when we take the photos, or when the facial recognition techniques, when we unlock the phone with our face or with our fingerprints or whatever it is, the sensors. So each and everything works on um, with the help of machine learning. Or maybe when you get the recommendation in your Facebook, when you add your friends from your school, or maybe from your similar school, or maybe a similar college, or maybe a similar office or location, so it will give you the more suggestion on that particular genre. And same as in LinkedIn, if you're a data science, so if you add data science, then you will get a more request about the data science, maybe the job opportunity, maybe the people, maybe the webinar, and all such thing. Correct. And also the Amazon products, like the Amazon recommending system, this is the widely used, the most recommendation system, the Amazon, and also the Netflix. When you buy any purchase thing, when you buy any any product on Amazon, so behaving your previous purchasing habit, it will give you the suggestion. Like suppose if you are a very tech geek, and if you love gadgets, if you order maybe iPhone or maybe iWatch or something, so it will give you the more suggestion similar to that, right? Maybe a Apple iPod, or a earphone, or something short like. Yeah. And and it is so these all are the practical and the real world examples where we are using each and every day, and we are surrounded by the machine learning. And the banks using machine learning to detect fraud transaction in real time. So this is a little bit complex problem, we'll go deep dive into and maybe upcoming classes. Yeah. So these are the popular machine learning and AI use cases. So how does the machine learning, so we are not going to the AI right now, but yeah, this is just to hang off a little bit, how the machine learning works, and how the AI, what all are the use cases, what all are the application of AI and the machine learning. So as again, I said, the smartphones and the voice assistants, I think everyone knows uh the in the Windows phone, like we use the Alexa, and in the iPhone we use the Siri. So like whenever, so these help us for the voice assistance. Like if you want to find the petrol bunk nearby your location, or maybe like a restaurant, or maybe like like whatever it is, maybe a movie theater. So you, like what exactly it do, like it will convert to your speech to your text. So that is called a NLP, natural language processing. So we will learn like in our upcoming classes as well. So machine learning, like perform really well of all these applications. And you can also like say the chatbots. So you must have like seen the chatbots whenever we reply anything on a chat. So it will like immediately give you the instant reply, like even though there is a no person is available, right? So how does the chatbot work? So it is again work on the basis of AI and machine learning techniques. Yeah. So machine learning, basically it is not just the concept, it is the concept definitely, but yeah, it is the playing around the tools and techniques, and how we can redefine our business domain task to get the the precise output. That is something all about. Yeah. Again, like as I said, the recommendation system, which I have already explained. Like you can see the e-commerce sites like Amazon and Flipkart, and book sites like Goodreads. Like if you are very if you're a bookworm, and if you like suppose a particular genre, let's say a fiction, so it will give you the more suggestion regarding the fiction genres. Or maybe if some of your friend likes and if some of your friends like horror, so it will give you the suggestion of horror as well as the fiction. And the movie service like IMDb and Netflix. Yeah, the IMDb, like how it works, like we can analyze the reviews and the IMDb ratings, like if the rating is 4.5 or 6.5 or maybe a 9 or maybe more than that. So before going to the movie theater, we can analyze, okay, whether the movie is good or bad, right? Then we decide like we should go or not. So how does all these things work? So the recommendation system, the sentiment analysis, involves very deeply in all these techniques. And Netflix, again, it is same as a Goodreads. If you like to watch a comic, if you like to watch a thriller or maybe a horror, correct? So it will give you the more suggestion like towards on that particular genre. Yeah, and the hospitality sites like MakeMyTripBooking.com. Yeah, so this is definitely it is a very widely used in the airlines as well as in the booking sites. Booking.com, I believe it is just for the real estate, definitely. And the Make My Trip, how the price vary, the surcharges or the price when you go to the and book for a airline ticket and a Vistara or maybe a Go India and the Go Air, and if you just keep like checking the particular price, the price get differ. So because the every airlines, because every company or every organization surrounded to with the machine learning, like they all are depend on the machine learning things, so that they can improve their business ideas, and they can improve their efficiency. So the whole idea is, if we can tackle the customer sentiment, if we can tackle the customer mindset, and so we can play around with a lot of uh, all this technique, and we can achieve the our outcomes. Yeah. And the food aggregator like Zomato and Uber Eats. So yeah, definitely these all are the real life use cases. Like Zomato, maybe pick, like suppose if you book any uh like like you know if you suppose if you book like a particular, like a food cuisine in a particular Zomato, so it will give you it will reach to your house within 30 minutes or maybe 40 minutes. Okay, so how all these things get detected? Because and there are a lot of the food delivery boy running around the city, but whosoever is the closest, so they will receive the application first, and accordingly and he will pick the particular the food from the nearest restaurant and comes to your house. So we will learn of all this thing in our upcoming classes. Yeah. So this is something which the most dominant thing we all are using, the email filtering. Like maybe I think many of you must have received the thousands of message in a monthly basis. and the messages may be a promotion or maybe the spam message which like has a no use. And so what if like suppose this is a scenario, if you are like sitting on your laptop, and if you are receiving a lot of like a spam message, and if you have any particular message maybe of such like such kind this kind of webinar, or maybe like some any job openings or something like that, so there is a high chance you can miss that information. So that is why the Gmail has like has segregated into the three different domains, like the primary, social, and promotion. So whatever the message which is the promotion thing, so it will directly go to the promotion folder. And if something which is like encouraging you, some of the events or something like that, it will go to the social. And whatever the prime message, whatever the important message, you will receive on the primary sections. So this machine learning algorithm immediately categorize the email into one of these levels as soon as you receive the email, right? So that you cannot miss the important information. And yeah, and the last one, this is definitely my favorite one, the self-driving car. So this is a little bit complex. So like this is not specifically work on the machine learning. Yeah, machine learning definitely, but yeah, as well as like the AI, that is artificial intelligence. So using the hardware and the machine learning concepts. So like how it work, like in a self-driving car, like you must have heard like the Tesla and maybe the Ford, they have already like come up with the self-driving car. So self-driving car has a lot of sensors, and the sensors they detect like this concept is actually what we call this concept is exactly the computer vision. The computer vision, like there is a one technique. It's like similar like as I said, the machine learning and all such thing. So it's a open CV, and the computer vision perform this task very precisely. Like there's a lot of sensors which is like loaded with the self-driving car. It's more than 200 300 like sensors. So these sensors are capable to detect all these features, like detecting object around the car and detecting the distance between the car in front. And like suppose if any pavement is passing like across the road, so it will automatically stop. If there is a traffic, it will automatically stop again, and it will stop in the traffic signals, and it will detect the weather condition. The wiper will automatically on if it is raining, right? Yeah. So like yeah, you can say the self-driving car is the most prominent and the most widely used like in this current like era. Yeah. So now we'll jump to this concept little bit more uh, like towards the machine learning. So the supervised and the unsupervised learning. So I'm not expecting you guys like to by heart these terms as of now, because as we learn more, so you can easily identify what is supervised and what is unsupervised. But I just want to understand you guys, like you can just understand a little bit of like how this thing, what is this term. That's it, I think that is enough for today's class. So like in a layman language, I would say the supervised is something when we have the target variable is given, and the unsupervised when we don't have the target variable, we can recognize through the pattern. What does this mean? So this mean is, I think there is a spelling error here. Yeah. So the main difference of this two type of like the two type of this like techniques. So the supervised learning is like basically based on the ground truth. In the other words, we can say like we have the prior knowledge of what the output values for our sample should be. So let's take an example. Yeah. So I think you all must have seen this picture. There is one baby and there is a two picture. One is apple, which is in red color, and one is banana, which is in typically green or maybe yellow. So what exactly it does? So like for example, we have shown the two pictures to a baby, and we told the baby that the first picture is an apple and the second picture is banana. All right. And here the child has to remember the color and the shape of the banana and apple, like both. So we will learn with few trials, like we can tell the baby like this color, this is apple and this is banana, and this is specifically for this color. apple, and this is specifically for this color banana. All right. And after that, if we show him a picture of the fruit other than a banana and an apple, he might say, yeah, this is a banana, because the baby doesn't know of any other fruits, like except of those fruit, like a banana and apple. So the like if we show any of the fruits, the baby might say banana or apple, or maybe he can just mix and match. Let's say what he would say, like a banana. Why banana? Or maybe he can say apple. So he would say banana, but banana is in green, a red color, which is weird, right? But here the thing is, so what we told you, like supervised learning simply means we are asking machine to learn by prior information. Like whatever the information we have given, the machine will learn only with those, those information. Like they will not use their brain. So the thing is, like if we give the wrong information to the machine, so it will so it's like a garbage in garbage out. Correct. Like if we give the wrong information to the machine, it will give you the wrong result. It will give you the right information, it will give you the right result, the right outcome. Okay. So I think like you must be a little bit clear with this concept. I will definitely explain you in a few more classes. So what happened is, because we already define only two levels here, and we're asking to identify any of two levels, this is called supervised learning. I think you guys must have understood. Now now the common algorithm is supervised. Yeah, so this supervised learning we are typically we used in a logistic regression. So these are all the algorithms which we will discuss in our upcoming classes, like logistic regression, naive Bayes, support vector machine, artificial neural network, and random forest. So don't get confused with anything, because we'll definitely discuss in more detail in upcoming classes as well. So now we talk about this unsupervised learning. Just hold for a second. We have cleared the supervised learning. Now we can talk about the unsupervised learning. So here the unsupervised learning means, like, again, let's take the baby example. And here the baby, like, he doesn't have any idea, what all this picture are. So we have the pictures of about like dog and cats. Okay, and how they look, because every dog has their own significance, and they look differently. And every dogs, the different breeds, or maybe a different like a color, or the different height and size. So we just provided him a group of picture of cat and dog, and now we are asking him to separate our group picture into individual categories. Like previously, the baby had an idea about bananas and apple, because we have provided him labels, right? One is like X and Y, but here there is a no label. So when there is a no label, the baby has to recognize with the pattern. See, the pattern means like the cat has the straight ears, and maybe the dog has the the down hairs, or maybe the cat is small, or maybe the dog is too big. So the baby can analyze with the patterns. So there is a when there is a no such target, when we don't know what we are trying to achieve, so we have to figure out with the patterns, and with the help of pattern we can analyze. Correct. Yeah. So you can see, like I have mentioned, like there's a two three things here, the difference between the quick you can have a quick look over it. Like the supervised learning means input data is labeled. Unsupervised learning, where when the input data is unlabeled, and using a training set and using the input data set. And supervised learning. So now this is something the classification measurement. So we have the lot of classification measurement. Like first of all, you have to understand what is classification. Classification means when we are distributing any terms into a two or three, or maybe a two or more different groups, like a binary form, like maybe 0 1, or maybe a 2 3 4, or any forms. So in that particular time we need a classification measurement techniques. Like when you predict any model, Okay, when you build any model or when you perform many tasks, so you have to identify, right, whether this task is really good or not. So how you will calculate, like what kind of accuracy is it, how much error rate, like what is the what is the precision, what is the sensitivity, what is the recall of all such. So these all are the jargons in data science terms. Okay, so here the confusion matrix, like why we call this confusion, I'll tell you. The confusion matrix is a 2 cross 2 table that contains 4 output provided by the binary classifier. Okay, so the binary classifier is always means 0 and 1, and the various measures such as error rate, accuracy, specificity, sensitivity, precision, and recall are derived from it. So this is something classification confusion matrix. So what does this mean? So in the left hand side you can see the actual class, and in the right hand side you can see the predicted class. So in the first column it means true positive, and the second one is false negative, and true negative, and false positive. What does this mean? That means like we are, suppose the person is a diabetic, and we are like, and actually he's a diabetic and we are predicting like he's a diabetic. Like, make sense? The person who is actually isn't diabetic and we are predicting like he's a diabetic. So that means it's a true positive. And in the second, the false negative. So we are predicting the person is like diabetic, but we are predicting the person is not diabetic. That means it's a false negative. And here in the like true negative, so what we can infer, like the person, like he doesn't have the diabetic, but we have predicted, like our machine, our model has predicted like he's a diabetic. So it can cause the patient life, right? Like the person is actually like he's not a diabetic, but our prediction like tells the person isn't a diabetic. So yeah. And in the false positive, like the person who is not like you can say uh, so this is false positive means the person is not like a diabetic and we predict he is not diabetic. It is just opposite to the true positive. Correct. So like where and how we can use all this thing, so we will learn about like in a upcoming classes as well. So but these all are the techniques, like which is widely used in machine learning. Basically when we are using the binary classification problems, like with the again I said the 0 and 1. So these are the basic measure derived from the confusion matrix, the error rate, like how we can find the error rate, accuracy, sensitivity, specificity, precision, and F score. So these, so what I would suggest you, like before jump to the machine learning concept, it would be really great if you can just brush up your statistics, like what is T score, what is F score, what is mean, median, mode, and Z score. Like if you are aware of all this thing, then it will be a like pretty much easy to understand of all these concepts, the machine learning concept, because we are going to use all these techniques in machine learning. So I would say, like there are a lot of open sources which is already available in the internet, maybe YouTube, or maybe you can go to the medium analytics vidya and you can brush up your concepts again. All right, so moving ahead, so we can jump to the data visualization. So data visualization is the most important techniques, like we can use in data science. The thing is, like see, the stories and the visualization, like give you the more sense when you understand any particular a task or maybe an idea or maybe a business problems. So if you have, so I think many of you heard, like there are a lot of visualization tools is already available, like let's say a Tableau or maybe Power BI, ClickView, and all such techniques, which will give you the fancy and the very easiest way to build a dashboard, like a sales prediction dashboard, or maybe in a website, like you can see the lot of visualization things. So visualization can attract you a lot more, and it will help you to understand the story behind the contest. Correct. So but there is another way, like using the Python, because since we are using Python, so we will learn this Python because like we are not focusing on the Tableau, So if you know to plot all this data visualization concept in Tableau, it's really good. But yeah, here we will discuss only about the data visualization, how we can use the data visualization using Python. So the basic charts in Python using Seaborn, Pandas, Plotly, and there is a storytelling from plots. Yeah, of course, as I said. So these are the libraries, like So I think most of you, for most of us, like this, libraries are like very new and maybe different. Like what is Pandas, what is Seaborn and Plotly. So I will explain you when I take you through the case study after this, after finishing this. Okay, so don't get confused. So, and again, the plotting library in Python, there's a library called matplotlib. So matplotlib is basically a library. It's a predefined library. It will help you to to things get easier, right? And the Seaborn is a library. So it is a like it will help you to build the statistical graphics in Python. So Seaborn is always on top of matplotlib, and the plotly it's again. So these all are the libraries we can using of all these libraries we can build our uh, like visualizations, like a graphs, because we are not talking about just the only graph. We're talking about the statistical graph, which can give you the percentage, which can give you the clear picture and the idea, how much sales is going up and down, like how much, let's say, the coronavirus. So maybe you must have seen like everywhere in the news, or maybe in the in short news, like how the coronavirus peak is going up and down. And let's say the India has, and recently I have seen one example, uh, like the 1 lakh cases in India, the coronavirus cases will reach, it will take around 64 days. But comparatively, the other states like US, France, or maybe Germany, and they took like merely, I think, 25 days to 30 days to reach 1 lakh cases. But India, since India is taking a really good precautionary measure, so we can say, the 1 lakh cases in 64 days, which is a decent practice. So this can, so these all visualization things can give you the clear idea, right? Yeah. So now the types of plot. So what kind of plots we are going to learn here? One is a line chart. Like I will show you how the line chart look like. The line chart basically when we have the two numerical variable. So now what is a numerical variable? I think if you are already aware, that is fair enough, but I'll explain you once again. So numerical variable means like when you have the like order variable, like a 0, 1, 2, 3, 4, 5, or this kind of order variable. So we use the numerical variable. And categorical variable means when you have this kind of variable like a low, high, medium, or when you have the differentiation between the maybe a grade A, B, C, correct? So these are the categorical variables. So we will explain more about this. So when we are, so this is just like you can just have a look, and then we'll quickly move forward to the visualization like code. So the line chart is basically when we have the two numerical variable in the x and y axis. When we have the x and y axis both are the numerical variables, we can plot a line chart. And the bar chart when we have the one categorical variable, either x or y, and one is numerical variable. And the histogram, like one numeric variable, area under the curve is 1. So histogram means the continuous I will show you like how it is look like. Okay, so don't get confused. And the box plot, I think you must have heard this is the very first time. Box plot is something which we used for the outlier detection. Let's say in a classroom we have 20 students or 20 employees, let's say, and our average salary is likely, let's say 10 lakhs per annum. And suppose Mark Zuckerberg enters in a class, and and his salary is, let's say, how much? A 10 million dollar. Okay, so and our salary is a 10 lakhs per annum. So that means he's a outlier if on this contest, because we can take a mean of all this. Suppose and I'm talking about the average salary in a class, someone has a salary of, let's say, 14 lakh per annum. So somebody has like a 4 lakhs, 5 lakhs, 6 lakhs. It may vary. Okay, so we can take a average easily. But what if the someone has come and who has a drastically a very huge salary? So it is really hard to find a salary of a one typical person. So in that case, we have to plot a box plot. So box plot can give you the complete outlier, because we cannot negligible, right? We cannot negligible the factor which can create the huge impact. Sometimes we can drop the outlier, we do not consider the outlier, but sometimes if it is affecting your business, so we have to consider it. Correct. Yeah. And the fifth one is pie chart. So the pie chart is something which will give you the very vague idea. So nowadays we don't use the pie chart anymore, since maybe you can see the election polls, like a BJP Congress, or maybe like a like a left or whatever. So we can plot a pie chart like who is winning this election. We can easily plot, but there are like other plots they can perform really well, so we don't use specifically a pie chart. And the scatter plot, this is something again new, and this is we plot when we have the two numeric variables. So I'll show you like in a graph. So here like you can, and yeah, so now you must have an like a question like, there are a lot of there are a lot of plots, so which plot we have to use when? So when we are doing the univariate analysis, what do you mean by univariate analysis? Like a numeric data and histogram, box plot. So you have to remember of all this thing like a categorical data or maybe a bar chart. When you are plotting all this thing, that is called a univariate analysis. I will like again explain you, so it will give you the more clarity and the sense when we discuss the code right now. And the bivariate analysis, when you have the if we have the like suppose here like I have mentioned the scatter plot to numeric variable. So when we have to plot like this kind of plot, so we have to use bivariate analysis when the x and y both are numeric, and when the one is numeric and when the one is categorical. But since again we are plotting the bar chart, because the bar chart can be plotted between the two different variables. Okay, but when we have the different variables x and y, then we can consider this as bivariate analysis. Okay, so I think don't get much confused of all this thing. We can quickly jump into our code. Just give me a moment. Okay, so this is so I will not like going to show you the like code by each and every line like how I'm going to use. I will just show you the little hang of like how this visualization look like, because whatever I have just explained you in the data visualization thing, because this is most important like in your whole life as a data science career. So you have to specifically use of all this libraries and all this visualization, right? So here you can see like we have to, and how we will set up all this thing. I think you already have aware like a little bit. This is the basically a Jupyter notebook platform. I think Vinayak has already took the class and he has already explained you how the Python works, so you must have a little bit of idea. If you if you are very new of all this thing, then maybe you can go back and brush up your skills on Python first. That is a prior thing, then you can uh, you will have a more sense. So here we just install this thing like import matplotlib.py plot python plot as plt. So what it does, like as I again told you, like the matplotlib is basically we used, so this is a predefined library, so I mean, you don't have to do anything, you just have to copy and paste here, that's it. In a cell it will give you the um, like the plots, like how the plots should be look like, and the pandas. So pandas is basically for the label data pre-processing. we use the pandas for labeled data. So we discussed, right, like how the supervised learning works and all such thing. Yeah, and the numpy we used for a numeric data. When we have a lot of numeric data, we can use the cbon. Again, the cbon is always the top layer. So as it again give you the statistical plot, it will give you the more sense. Yeah, so we can check the which version is it. So yeah, plotly modern visualization for the data era, the line chart. So as I told you, right, when we have the two numerical variables, when x and y, and the situation where we have the y value corresponding to x value. So we can, like, suppose x has an array 1 2 3 and y has an array 3 y or 6, or maybe you can say the matrix 1 cross 1 matrix. So we can, this is the code for this. It's a simple code. So we can, like, you can say, like, you can define, like, in your x-axis you can label like what exactly you're trying to find, maybe your age and salary or whatever it is. So this is the line plot. Yeah, now I can explain. Yeah, so this is the most important, the basic bar chart in plotly. When you have the one categorical variable and the other one is a numeric variable, so you can see in the x-axis there is a dependent variable, that is a 0 5 10 15 and 20. These are the all are the numeric number. Sorry, this is the dependent and this is the independent variable. In our x-axis we have the dependent variable called x, y and z. So these are the categorical, because these three are the different thing. That is why this is the categorical variable. And I will take one use case and maybe you can get a clear idea. Yeah, and this is the histogram in plotly. Like when you have the one numeric variable, not exactly this. Yeah, histogram of a like a 1 lakh random numbers. So when we have the 1 lakh random numbers, so it's a continuous value output. It will give you the, like, the like a plot, something like this, which also called the normal distribution, because it attains one peak, then again it goes fall down. So if you can see, there are a lot of different small bar charts, but they all are adjoined together. Okay, so because it has a 1 lakh random number, so that is why the picture is not clear, but I can show you like how exactly it is look like. And this is something which I was talking about, the box plot. When you have the complete outlier, like suppose the minimum, that is the first quadrant, quartile, median. Like, see, you can easily find the median or the mean when you have the more or less the same number of information. But when someone is like come and he has a huge salary like a Mark Zuckerberg, so in that case we have to find the outlier. So this is the outlier. See, this is the graph, but you can see, like, here you can see this, the dot, that means the outlier. Yeah, so this is the, we use all this thing. So this is the typical code for outlier. You have to set the seed is for the better reproducibility, and you can just play around with all this thing, like a name, box one, marker, dictionary, color you can change, like trace one, because there are two trace, right? One is a trace one and trace 0 and 1. Yeah, so whatever the information you will give in your code, so it will give you the same output in your visualization. Yeah, and this is the bar chart. Bar pie chart. I think you must have aware, we use like a red color. The red zone is the most affected coronavirus cases here. Maybe the green and the blue, which has the like a safest zone. So you can like infer like something like that. And yeah, when we plot the scatter plot is something when it's a kind of, like, you can say, not exactly 3D, but yeah, it will just look like a very scatter manner, like, you can say, and like this kind of, these all are the data points, these all are the information, these all are the coordinates. When you have this kind of information, when we have the two numeric variables, and one categorical variable. So let's say, like, you can plot here, like you can just cross think. Okay, let's not get confused because I think there is a problem in my system. And yeah, this is also we don't use very widely, but yeah, when we group something, like when we label something, suppose there is a lot of group and there's a classification. So we can, when there is a classification of like the number of people, the number of gender, or the number of like a society, a religion, or something like that. So we can group into this kind of like visualization technique, which is called a tree map. And this is something which we very like widely used in our visualization. There is a heat map. We'll give you the correlation, like correlation. So when we discuss about the linear regression, so it will give you the like the more sense, like how this heat map works, like when one variable is correlated to the another, and the correlation should be one. And like I will explain you in the next class in a detailed manner, like how we can use the heat map. So let's take a very quick, because we are running out of time now. Okay, so I'll just go like take you through the case study. So this is the case study, like whatever we have discussed right now, so we can just like learn it here. So this is something like I have explained you about the data visualization, but yeah, mm, this is something which is all about the data manipulation. So data manipulation means like when we build our model, before building our model, we already have the data, but the data is in a very vague form, in a very like the undisturbed and the unstructured manner. So we have, so as a data scientist we spend our lot of time, or maybe like suppose if you have a given task for a 6 months in any organization, so we spend like typically 3 to 4 months just to prepare our data, to cleaning our data, to pre-process our data. Once you have the data ready, then you can like achieve anything you want, right? So like and this is very important, like to learn all this thing, like how to prepare data, like how to pre-process your data. So like this is a use case of mm, so there is a one HR data description is mentioned below. One is education, like below college, bachelor's, master, and doctor. And environment satisfaction, low, medium, high, very low. Job involvement, job satisfaction, again performance rating, low, good, excellent, outstanding. And relationship satisfaction and work life balance. So these are all the factors which we have given. So again, like as I said, right, like why we need machine learning, when we have the multiple features and we need something out of it, right? We need a correct sense out of it. So in that case we need machine learning, because machine learning performs really well when we have the huge data, when we have the multiple columns, when we have the like the hundreds of columns. So the machine learning performs really well. So we can make a much more like meaningful insight out of it. So this is like we read the data, like so like the thing is, in your local system you have to download. So data is in form of like so whatever we are learning as of now, the data is in form of rows and column, so which normally you will get in Excel file and in CSV format. All right. So you must have the data in your local, in whichever the folder you have the data. So you can just write like so this is like HR underscore data. So we are just passing the argument, and this is the code, like PD means again the pandas data frame dot read underscore CSV, because we are trying to achieve the CSV file in a bracket, like HR underscore iteration dot CSV. So I must have this file Since this is not a Jupyter notebook, this is the HTML file, so I don't have the code right now, but in the next class I'll show you like how we can extract the data in our Jupyter notebook. So you can just just have a little bit of hang of it. So hr underscore attrition dot csv, this entire name, this is a file which must have present in my local system. Only then I can get my data here. So once you get your data here, okay, then after that you can do your pre-processing. Now I want to see what kind of data I have, because in Excel you can see easily, okay, these all are the columns, these all are the rows. But how you can see in Python? So in Python you can see, so you can type this command hr underscore data, because hr data is again is my argument dot head. And so when head means it will show you the first five rows. So you have to remember this thing in Python. Whenever we talk about the five rows, so it will count as from starting from 0, 0, 1, 2, 3, 4. And you can mention it here in bracket you can mention 10, so it will give you the first 9 data, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these all are the columns, like iteration, business travel, department, distance, and so on. So there are 31 columns. So you can see in this data there are 31 columns is already present. But we have to play around specifically with this data, because these are the categorical data and maybe the rest data are the numeric data. Like how you can identify, like suppose department, sales, research and development, these all are the categorical data. Distance from home 1, 8, these all are the numeric data. These again are the categorical data. These are all of the categorical data. So mostly we have a lot of categorical data. So the whole idea is our machine will not understand the categorical data. Our machine will only access in the form of the numeric data. So we have to convert this categorical data into numeric data. So there is a lot of techniques like how to use this categorical data to numeric data. So once we have the numeric data, then we can perform our task. Then we can build our machine learning model, and then we can find the accuracy. Correct? Yeah. Now you can check your data type. Like suppose I have the 31 columns, right? So how I can identify, so how I can identify what kind of data I have and which data is like, suppose, because when you have the hundreds of columns, so you cannot count each and every data, right? So there is a specific code for this. Like you can find which all are the integer numeric value and which all are the float, because float is also a numeric data, and which is the categorical data. So if you can see, the age is a numeric data, attrition is a object, that is a attrition is what is a categorical data. Yeah, the business travel and all such. Sorry, no, not here. Yeah, attrition, you can see these all are the categorical data. Business travel are the categorical data. That is why these all are the objects. You can see these all are the categorical data, and these all are the integer, that is a numeric data. So now we can find our null value. So see guys, don't get confused, because every time, every single time we have to do this task. So you will be a, get uh, a very pro in of all this data techniques. So you don't have to memorize or remember of all this code. I'm just taking you through how the what all things you have to understand in the data manipulation. What all things you have to understand when we talk about the data visualization. The data manipulation simple means like we are preparing our data, like what we have to do with our data, before we build our model. So here we find the null values. Null value means like in your data, because these rows can be in the thousands of rows, right? The rows can be thousands or maybe millions of rows. Here it's just the only 11 rows, and you might have the lot of values which is not relevant, a like a null value. So null value in the data, it represent as a null, NaN, or maybe it's blank. Okay, so we have to find, before jump into our analysis, we have to find all this null values. So there is a code for it, hr underscore data. Hr data is similar, this is our like uh, which we have used here. the argument we have passed. So we have to keep using this thing every single time, because you are just changing your command, but this thing is remain same, right? So hr underscore data dot is null dot sum. So when you like it, what it will does, it will like calculate all the means, and it will give you the null value. So you can see in age we don't have any null value, in iteration we don't have any null value. So we typically have no null values of all this thing. Yeah, checking the number of unique values in each column. So I would say, like, you shouldn't be bothered about this thing because this is little complex, and I will explain this later. So don't go to this thing. Yeah. So this thing which I would want to, and yeah. So when you already filter out what is the numeric value, what is the categorical value, so you can just simply type like cat underscore column. So you can able to see like these all are the categorical data, like in your system, in your data set. And here, like you can see the categorical attribute summary. Like so if you want to find, guys, just give me a second, because I think there is one application is open and it is keep disturbing me. Yep. Okay, no problem. So here, like you can see, like see these are, so this is the technique, like which can which we can see like what kind of, see, you don't have to manually like every time you have to do like a mean, you have to find the mean, median, mode, and all such thing. Like if you can write this code hr underscore data dot describe include all, so it will give you all this thing, all the information like the frequency, the mean, the standard deviation, mode, and like the 25% quartile, 50% quartile, 75% quartile, and maximum. So these are the like a data description, like the data summary. You can say like what kind of data you have and which data tells you what. So all this kind of data you have, see here you can see these are the column, like age column, and it has 1470 count, that is rows, and it doesn't have any unique feature, any unique value. So yeah, this means is simple, like a gender is like a, maybe a male, like a two male and a female, or whatever it is. So I think, guys, like so we are done for the day. So all this thing I have explained you, and for the next class we will learn about the linear regression, where I can explain you like how to write the code and with the concepts, like with the help of the case study. So I think, guys, you must have enjoyed the session. So if you don't understand anything, so please don't hesitate to comment below, and also just like write what else you want to cover me, like if you don't, if you need anything which I can improve in this learning, which might help you. So I can do that. So I think the rest thing, I think whatever I have taught you today, that is all about the machine learning, the basics of machine learning. And slowly, so we have the syllabus, like we will go each algorithm in detail with the help of case studies, so that you will do all this data exploration, the data cleaning, and the visualization, and how to build the model, and what are the techniques. So yeah, so I think that's all from my end. Thank you so much, and have a good evening. Bye bye.